In this lecture, we discuss photocurrent depending on these four factors: intensity of UV light or incident radiation, frequency of UV light or incident radiation, electric field, and potential difference between C and E plate is the emitter plate, C is at collector plate, and here must be when at C is at when photoelectric effect is possible, we place always C in positive, okay, and E is negative, and there is depending on some factor, okay. And another fourth factor will depend, that's the material, nature of the material, obviously in emitter plate, okay, UV light or incident radiation on photocurrent, okay. So if you see that diagram, if I draw it here, there is some gap here, and there is some plate, okay, and this UV light falls on that emitter plate, okay. So first, photocurrent versus intensity of incident radiation or UV light. If a more intensity, okay, so more intensity means more photocurrent, means actually more intensity means the more photoelectron. So more intensity means more photoelectron, and more photoelectron moves towards the acceptor plate or accepted by this plate, and we get some milliampere meter here. We get some more current here. So that's why these two are directly proportional. So IPH proportional to intensity of UV. So if I plot these two, the photocurrent here and the intensity here, we get directly proportional. So more intensity of light falls on the emitter plate, we get more photoelectron, and if you get a more photoelectron, we get a more current, more photocurrent, okay. So here the photocurrent, actually the photocurrent is mainly depend on the number of photoelectron, okay, number of photoelectron emitted by the emitter plate per second. So here photocurrents depend on, number of photoelectron are emitted electron per second emitted by the emitter plate. That's depending on. So photoelectron is very important. The number of photoelectron emitted per second is that emitted. Actually get that I equal to Q by T here. So Q equal to NE. Okay. And more electron, it's more current. Okay. They are directly proportional here. Light of frequency. Here the frequency is fixed. Okay. The fixed frequency here. Fixed frequency here. Okay. Okay. Now I discuss. Skip to 2 and move to, now discuss electric field or potential difference between cathode, actually these are called C, that's a cathode, C plate, emitter plate, and sorry, these C are the collector plate, okay, sorry, these C are collector and E for emitter, okay. So just jump this part, okay. It'll you discuss what is frequency after that, so for better understanding actually, okay. For if I now apply some potential difference, okay, here, so apply some potential, number 3 here, photocurrent versus potential between emitter plate and collector plate, okay. So here this case, to fix the frequency fixed, and also intensity, obviously UV light or incident radiation be fixed here, okay. We just change potential difference and we get some photocurrent, okay. So Now we increase the collector plate potential and emitter plate potential. Okay, actually the one plate potential must be increased, other automatically increase. Now we increase that potential. So diagram is now look like this. Okay, I photocurrent here. Okay, there is some potential. So potential difference of collector plate collector plate. If a potential difference increase, you see that the photocurrent is increase here. Okay, so now the diagram is look like this. Increase. After some value, we get current here saturate. After some value, after some values, okay, current must be saturated. Now, if I further increase potential difference across the collector plate, but photocurrent here will be saturated. Here you see that photocurrent after that point, this potential, photocurrent here saturated. Why photocurrent saturated? That's very important. Why photocurrent saturated? Okay. The conclusion is that so metal, these emitter plate have free electron. If all free electron are emitted from these emitter plate and all free electron are now in collector plate. So there is a no free electron here. Okay. So there is a no zero free electron in emitter plate. All are in free electron now in collector plate. So that's why. So there is a no electron move from emitter to collector plate. So that's why there is a no current here. If further increase the potential difference, but there is a no photoelectron. So here is a no photoelectron because all free electron are in now acceptor plate. Okay, so that's the photocurrent be saturated. Now, if intensity of UV light is fixed, okay, suppose I say that is the intensity be here, that is a I1. Now again we further increase the intensity of light. Okay, so now diagram is look like that. Again some value we get I2. Okay, now further increase the intensity, we get some this diagram, that is I3. Okay, after some potential value, all are in photoelectron are now in acceptor plate. So if intensity increase, so there's some little bit free electron are increases here. So if little bit free electron increases, we get some more photocurrent. So here we see that saturation values increases. If intensity increases, suppose the I3 is greater than I2 is greater than I1, you see the diagram, the saturation value, saturation current, ISAT is increases. ISAT is increases. But now here, if I change the polarity of that battery or potential plated, we change the polarity and this called a retarding potential. If I change the polarity of that electrode, so now the polarity is now look like this. Here, suppose the polarity now the window is a emitter plate, these are collector plate, here the emitter plate, and the polarity now the collector plate be the minus. Okay, so electric field in that direction, emitter be the plus. Change the polarity with the help of commutator. Okay, so here when the polarity is reversed, so if the electron fall on UV ray here, so if the electron are escape from the metal surface emitter plate but slightly back to the same metal. Okay, so if electron released from here but due to the potential difference, here is a negative, so the electron with a negative, there is some repulsive force here, that's why these are force push the electron back to the metal. If the electron push back to the metal, So there is no photoelectron. So lesser than photoelectron, less photoelectron. If less number of photoelectron, okay, so if less number of photoelectron, we get a minimum value of current. So if polarity is reversed, so current value is obviously decreases photocurrent and decreases at some point here. So at that point we get current value is 0. At that point photocurrent is 0, and here 0, and photocurrent is 0 at that point. And this potential value of this potential is called stopping potential. Is called stopping potential. Stopping potential means the maximum energetic electron. Those one electron, whose energy is maximum, that electron only jump that overcome that push and reach to collector plate, and that's when I reach here we get some current here. Those electron, only one electron, okay, only one electron, those kinetic energy is maximum, all not, just one electron kinetic energy is maximum, and that electron reach to the collector plate and we get some current. Okay, that's final electron. After stopping potential, there is a photocurrent with a 0. And you see that stopping potential is independent of intensity. If you increase the intensity, but stopping potential be the same. And this potential is called V0. Called V0. Stopping potential is independent of intensity. Okay, so here the only one electron, those kinetic energy is maximum. So kinetic energy maximum K max, that is overcome that last stopping potential. Just one electron overcome that push and reach the collector plate, we get some current. Only one electron. Okay, so here the diagram. This diagram actually represent some conclusion here. Diagram represent here. The higher the intensity is more saturation current. Higher intensity is more saturation current. Okay, high intensity means more saturation current. And another point here, the stopping potential is independent of intensity. Stopping potential is independent of intensity. Okay, here there is some frequency part. Okay, there is some frequency part. Now we discuss that number 2, photocurrent relation with frequency of incident radiation. Now discuss the 2. Okay, so here number 2 discussion here. So now the photocurrent versus frequency of UV ray or intensity of radiation, incident radiation. So here the diagram. Okay, diagram. So photocurrent here. Okay, so photocurrent here, and here we get some potential. Okay, so collector plate potential, that's the collector plate potential. Okay, so here we get the intensity with the same. Okay, the fixed intensity here discussed mainly fixed intensity. Fixed intensity. Okay, but variable in frequency. So if intensity is fixed, so you get some fixed saturation current here. So here saturation current fixed. That's the saturation current. I sat, because the intensity is one intensity we discuss here. That's why that fixed here. This is I stands for here current. Okay. Now if frequency is different, okay, of UV ray. So here we see that one, two, okay. So here we get three stopping potential. Okay, so stopping potential of 0, 1, obviously negative potential. Stopping potential of 0, 2, negative. Okay, here stopping potential, okay, that's very important, is a negative. Okay, these are in negative axis. These are positive x, these are the negative x. Okay, and that is minus v0, 3. And there are the three frequencies here, the frequency 3, frequency 2, frequency 1. Okay, so frequency 3 is greater than frequency 2 is greater than frequency 1. If frequencies increases, okay, if the frequencies increases, so we need a most potential apply here. Okay, more need a more reverse potential to stop that maximum energetic electron. Concept is like that. If a frequency increases, so this electron gets some extra energy, okay, to overcome that pull, that push, overcome that push, because there is a negative potential. Okay, so we need some more potential here to stop that electron. Okay, so that's the conclusion. More frequency means more energy accept than this photoelectron, and if a photoelectron gets more energy, so you need a more stopping potential to stop that electron to do not reach that collector plate. Okay, so that's why final conclusion is that energy of emitted electron depends on the frequency of incident radiation. Okay, so okay, so energy, okay, depends on energy depends on, okay, frequency of incident radiation. Okay, and if I block the diagram here, okay, so block diagram for better understanding. First block, get at the frequency first, get the UV ray frequency. If get at the UV ray frequency, so greater is the kinetic energy. The kinetic energy is more, Ke is more. If K is more, we need more stopping potential. So we need more stopping potential to stop that electron, to stop that electron to reach collector plate. Okay, we need a stop potential, we need a more stopping potential to stop that. Okay, so here now draw another diagram for, okay, there is a stopping potential, the stopping potential versus frequency. Stopping potential versus frequency. Okay, so here the two look like that. There is some two stopping potential here. Suppose V naught and V naught dash here, and there is some two metal here for metal A and there is a metal B. Okay, so there is some frequencies here, and these obviously here both cases the frequencies must be greater than threshold frequency. Obviously, okay, these frequencies must be greater than threshold frequency. So here we get here this frequency here, and here the frequency metal plate B here, and now the frequency. Okay, this frequency here is greater than frequency not here, and here the frequency is greater than frequency dash here. So that's why you get some stopping potential here. We need more stopping potential stop there. Okay, so stopping potential here, stopping potential mainly observe that the stopping actually graph actually represents stopping potential. Stopping potential is V naught is really proportional to frequency of incident radiation or UV ray. If more frequency, you need more stopping potential to stop that maximum kinetic energy of electron. Okay, that electron to stop that, do not actually our purpose is do not reach that electron, stop that electron, do not reach the collector plate. That's why stopping potential is purpose. Stop that electron. Okay, and suppose there is some cutoff, okay, certain minimum cutoff frequency, a certain minimum cutoff frequency, okay, certain minimum cutoff frequency, and that lead to stopping potential. So stopping potential, okay, and now the observation of that graph, okay, the very important observation. What is the observation? Kinetic energy maximum of that electron, of this is a photoelectron, photoelectron is directly proportional to frequency of IR, frequency of incident radiation or UV ray. If more frequency is more energy, so that's why more stopping potential to stop that. Number two observation, very important, frequency of IR, incident radiation or UV ray, is must be less than threshold frequency. If these frequencies must be less than threshold frequency, actually that's the minimum frequency to need that photoelectric effect. If we apply a UV ray have lesser than threshold frequency, so obviously we are stopper is very easy. Okay, stopping potential must be easy here. So because no photoelectron is possible, all electron actually all electron do not overcome that attractive pull. Okay, so if the frequency is lesser than that cutoff or no photoelectric emission is possible, so there is a no photoelectric current here. Obviously, effect photoelectric emission is not possible. Actually, the emission, this condition is emission is not possible. Okay. So independent of intensity, but here both cases are independent of intensity. Here discuss independent of intensity. Okay. Now actually summary that whole classes here. That's a very important summary. The summary. Whole classes. Summary of photoelectric effect. First we learn that is photocurrent. Okay, is directly proportional to intensity of incident radiation or UV ray. First, second, okay, when the frequency of incident radiation is greater than some threshold frequency. Here, when frequency of IR or UV ray must be greater than threshold frequency. for photoelectric emission. Okay, emission. And number 3, incident radiation. Okay, intensity of incident radiation or UV ray is directly proportional to saturation current. More intensity, actually the intensity. Okay, more intensity you get, more saturated current. Okay, so here stopping potential, but stopping potential V naught is independent of intensity. Is independent of intensity. And number 4, the threshold frequency, the very important concept. Threshold frequency, that's the minimum frequency for is more for photoelectric emission. Is actually the UV ray frequency of UV ray is greater than threshold frequency, but that's the minimum. Okay. And number 4, that last and number 5. Okay, as a very important observation, there is no time lag. This is fast process. These are the fast process. There is no time here. Okay, the independent of time, the fast process, no lag. Okay, here you see that in whole lecture we do not discussion of time. There is a time bounded here. Okay, these are independent of time. So that's these are the very fast process. Okay, so that's the photoelectric effect and photoelectric emission. Okay, so today in the class here, if you have any doubt, please ask in comment section. I will try to give the answer. So today in the class here, thank you.